Hi guys, in today's video we're going to be doing a very simple experiment that was first done by Isaac Newton back several hundred years ago, but it's still relevant today for teaching kids about the relationship between light and colour. To do this, it's a very low cost, easy to do experiment. All you need is some paper plates and different ways of spinning them. So you can do it using string, you can do it using a pencil just to make it like a spinning top, or you can use my preferred third method that I'll get to later. However, why would we do this? Well, it covers some outcomes to do with light generally. The outcomes at second level are more to do with reflection and refraction. Well, refraction kind of comes into this a little bit to do with the way light's bent. But really, it's just teaching us about colour. Now, as teachers, we often make bold assertions to the class when teaching science. And I think it's quite nice if we can find ways of actually testing and demonstrating those assertions. So the assertion that we'd be making here would be that white light coming in from the sun, is made up of all the different colours. So all the colours of the rainbow mixed together creates white light. And we're going to try and actually test that and demonstrate it. Now, one way you can do that is just using a prism. If you get a prism, hold it up, and we actually have a nice sunny day today. I could do this in a minute. We could hold a prism up to the sun, and we should see it splitting the light into each of the colours of the rainbow. However, another way we can do it is by actually drawing out all the colours of the rainbow on a disc and spinning them together. Now, I will say that the colours, I printed off this version rather than hand drawing it, although I would get my kids to draw it by hand, and I found it works better. You get a far more impressive effect if the colours are paler. These colours are a little too vibrant and a little too bright, and so you probably won't see it actually going white in this case. But you should see a merging of the colours generally. And it's quite interesting to talk about, well, if we've got all the colours there, why doesn't it go white anyway? Why does the vibrancy, the brightness, or the intensity of the colours actually matter? So you can talk about that as an individual point. So once we've printed off our disc or coloured in our plate, we're just going to put it on a loop of string, like so. Now, I tend to find this is a two-person job. I'm just using a retort stand to help me here. What we want to do is we want to spin up the disc. Now, this might be just a little bit too long, actually. This is tending to want to flop over, so it might not work perfectly, which will be frustrating. Once we've spun it up, you get one person to hold it. That's not too bad. And by tightening and letting the string go slack, that's it, flopped over there. But we can get the disc to spin. So that's the first way of actually doing this, and that tends to work quite well. The other way to do it is just to poke something through the middle of the disc here, and you can create a sort of spinning top with it. Okay, so that's another way of doing it. But by far my preferred method is to, if you have one, to get hold of a power drill with a little bit of blue tack on the end, and you just stick your disc directly to it. And I find that works somewhat better. Now, I'll demonstrate that in a minute. How is this an experiment though? So far this is just a demonstration, and while there is a time and a place for a demonstration, it's often better if we can make it experimental. Well, the essence of experiment is comparison, like I keep saying. So, in order to make this experimental, we want to be doing a controlled comparison of several different varieties of colour. So here I've gone for all 6 colours of the rainbow. Spinning that, will it go white? Maybe, maybe not. I could use the 3 primary colours. Now these are actually the primary colours of pigment. The primary colours of light are different. They're yellow, magenta and cyan. But I could try just yellow, blue and red, the primary pigment colour, spin that, see if it makes any difference. Alternatively, we could try just red, green and blue, because those are actually the only colours that our eyes are able to perceive, and every other colour that we see is just a mixture of those 3 colours. So as long as we're doing a controlled comparison, that makes it more experimental. So let's try these just out of interest. So we'll put this one on the disc, and because this drill spins so fast, it does often, it just flies off after a wee while. But we'll start. We definitely see that we get a bit of a change of colour there, which is cool. So that's it's again not white. If you use paler colours, you're more likely to get white. We'll try the three primary colours. Not dissimilar there, so there are some similarities between the two there. And lastly, we'll try the red, blue, and green, the only colours that our eyes are actually able to perceive. And that one went quite different there, so a very different colour. But by doing a controlled comparison of each of these and seeing what variables make it tend most towards white, that makes it more of an experiment. The kids really enjoy it. It's something that's practical, something that they can, they can really get stuck in with, and some valid teaching points to it. So give it a shot. Cheers.